A team from York University has scored top honors for building a prototype of a Mars rover. The students placed first overall in an international competition that was held in the Utah desert. They designed a vehicle that an astronaut could use to maneuver over the rocky surfaces of Mars. And for a closer look at that creation, we are joined by team members Mike Liscombe and Neela Maharaj. Good to have you here. Congratulations.
Thanks a lot.
How long have you been working on this?
Basically, the project started, I'd say, around September. So that's when we actually got members recruited. And then I'd say the actual design started in November, and construction began in January.
What are you studying?
Both of us are computer engineers. I'm an undergrad. Mike is a master's student.
Yeah. And Jesse and Bart over here helping you out?
Yeah, definitely. So
and who's this over there?
That's Mark Post.
And Mark?
Yep.
And all these guys are all in the program with you?
Jesse is physics. Bart is computer science, and Mark Post is actually an Earth and Space Science master's student, PhD student.
It's like the A-team. Yeah. It's like you got everything, you got everything covered. Yeah. I mean, this is fascinating, though. I mean, where do you even begin? I look at this and I just can't believe anybody put this together. How did you even begin to do it? And what did you learn about Mars that helped you create this and create the design?
Well, did you want to?
Mike? Okay. Well, we had to build a rover that could accomplish four tasks.
Yes, please.
Yeah, make it move.
Make it move.
So we had to build something that could accomplish 4 tasks. So when we were in the desert, we had 4 different goals, 4 different separate competitions. And
what were they?
The first one was helping a distressed astronaut. So we had to traverse some tough terrain and find the astronaut.
Okay.
Deliver a care package.
Okay.
The next one was a construction task. So we have this apparatus here, the arm. We use the arm.
Where's the arm? This is the arm here?
Oh, yeah.
Okay.
So maybe you can give us a little demo here and move the arm around.
Look at you.
So it can move, it has the ability to move up and down.
Who's doing that?
Bart.
Bart is, okay.
Yeah, it can move left and right as well. It has 2 servos here that can move in different angles, so one can tilt, one can pan. We can also tilt the entire apparatus.
I'm geeking out. This is crazy. Wow, that is amazing. Go ahead, sorry.
We can also tilt the entire apparatus. So the whole premise is to align ourselves to a plane of a space vehicle or a down space satellite or anything we need to tighten a bolt on. So we have this bolt tightener here.
Okay, okay.
And we have different cameras so we can see the arm from different angles and give us a good view from the control station.
So this was meant, obviously, it's meant to be handled remotely. I mean, that's the idea.
Oh, yeah,
that's right.
definitely.
So the premise is that we're NASA and we're on Earth. We're trying to do everything on Mars that we can.
Yeah. So you see, I mean, you can see obviously through the webcam, right? I mean, what you guys are looking at, it's on the laptop there?
Yep.
Exactly.
Okay.
Yep,
okay.
They're all over. There's a few up here, there's one here, there's one there.
Yeah, actually this system right here is actually pretty vital in the navigation task, which we scored 100 out of 100 on. And basically what it is, it's a bird's eye view system.
Yeah.
And it gives you, a higher perspective because down at this level you can't really see over hills and that kind of terrain. It's very important to see, where you're going to go right over that hill.
So the other universities you competed against, like those losers from Harvard and MIT and whatever, they all broke down. Right, you guys broke down in the beginning, but but you completed everything you needed to do.
Yeah.
They all broke down through it, right?
Exactly.
Right.
So we had a lot of technical difficulties right at the start line, as opposed to on the field. Whereas a lot of teams, they were, in the field, and then they just lost communications, or something would break down, like their drive motors wouldn't work.
Yeah.
And I guess that worked out to our advantage that we didn't break down in the field.
So what's the deal? I mean, do you think that this could actually make it to Mars? Seriously.
It needs to be TVAC tested. It needs to be space tested. Batteries respond differently in different temperatures. They typically hold less charge.
Yeah.
So we'd have to redesign some of the systems for sure. But as far as the structure itself, I'm not sure if you need such a massive arm to repair something on a space vehicle.
Don't be so hard on yourself. You won the competition.
Okay.
Yeah.
I mean, it's possible, right?
Yeah.
Just give me that.
Sure. We'll give you that much.
I'll give me that much. Congrats, you guys.
Oh,
thank you all very much. Really appreciate you guys coming on.
Oh, thanks for having us.
Now, let's see. Coming up next, are your light bulbs emitting more than just light? We're going to test some household items for electronic pollution.